Hi everyone, let's talk about the second problem of this biweekly contest 122. The problem is find if array can be sorted. And in one operation, you can swap any two adjacent elements if they have the same number of set bits, the same number of bits that are 1. You're allowed to do this operation any number of times, including 0. And we want to see if we can sort it. So for this number, we should look at a few examples. So something that we see from the problem statement is that we can only swap numbers that are adjacent. Okay, and they should have the same number of set bits. So if this is your array, the first number can be only swapped with the next number that have the same number of set bits. So something like this. So for example, all of them have 2 bits, let's say. Then this number can only be swapped with the next one that have the same number of bits. So this can be swapped with the next one that have the same number of bits. So that means all of them are in the same component. All of them are in the same sub-array. So for example, let's say this have 4 bits, and so on. This could have 1 bits, and so on. Okay, so we can just do what the problem is telling us to do, and at the end see if the array is sorted. And what do I mean by that is that sort this sub-array in place, sort this sub-array in place, sort this sub-array in place, and at the end see if the array is sorted. At the end, check if array is sorted. Okay, and is it necessarily going to be sorted in increasing order or decreasing order? That's a good question. Sorted. Let's look at the binary representation. Sort the array. So I'm gonna assume that it wants us to do in increasing order, but let's go and see if we get the wrong answer, or maybe I'm missing something here. If we get the wrong answer, we are going to try increasing and decreasing both of them. Something that we are assuming but needs to be proved is that you can sort a sub-array in place by using this operation. And this operation is swap any two adjacent elements. So let's have an example. This is important to notice. So let's say you have a sub-array which is A, B, C, and D, and this is the current permutation of A, B, C, D. And we want to see if we can convert that to D, C, B, A. And the answer is yes. Check. This is the answer is yes. Check what's the first letter. It's D. Find it in the original and start swapping that with the previous one. Then swap D with the previous one. Then swap D with the previous one. So the current version is going to be D, A, B, and C. So we have D now in place. Now find the next one in the final. So this is final. This is original. This is goal, final, goal, whatever. Find C. So in here, find C and swap C and swap C. And now C is in its place. So it's going to be D, C, A, B. So it's D and C are in their place. And now we have B in the final. So find B and swap it until it's in its position. And now we have D, C, A, B, and A. So basically, with just swapping any two numbers, adjacent numbers, we can have any permutation of a sub-array. So we should just implement this part then. We take the first number and we keep extending the current sub-array until the number of set bits are equal. And when we finish extending the sub-array, we sort that sub-array in place. And we do the same for the next sub-array. And we do the same for the next sub-array. And at the end, we just check if the array is sorted. Let's go and write the code for this problem. So we can have two indexes. So it's going to be int I equals 0, int j. While I is less than n, which n is nums.size, So this is kind of, we can do this with 2 pointers, I and j. So j becomes I here, and while j is less than n and num bits of nums I is equal num bits of nums j, while they are equal j plus plus. And when we are finished here, sort this. So sort nums.begin plus I and nums.begin plus j, and update I becomes j. And here, if is sorted nums, return true, otherwise return false. So return is sorted nums. Okay, so I need to implement these 2 functions. There are built-in functions. I'm just going to implement them to show you how you can implement it. So int numbits int x. So for int bit equals 0, and we can go up to 2 to the 8. I'm going to go just up to 10 anyway. Bit is less than 10, bit plus plus. And int num bits is going to be 0 if x and 2 to the bit, if I have this bit, num bits plus plus, return num bits. There are built-in functions, you can search and use them. And is sorted. Bool is sorted and a. So in order to check if an array is sorted, how do we do that? We start, let's say we have this array of A, B, C, D, E. So what we do, we ignore the first number and we start at the second number and we ask, are you greater than or equal to A? Are you greater than or equal to B? Are you greater than or equal to C? And so on. And if one of them says no, we return no. If all of them say yes, we return yes. So for int I equals 1, we start here. I is less than a dot size, I plus plus. If ai is less than ai minus 1, return false, return true. Okay, so if at some point it's less than ai minus 1, that is bad. Otherwise it's greater than or equal. Keep going. So let's try and see if this works. Yeah, true. And this one, true, false. Let's submit. Yeah, that's it. See you in the third problem of Biweekly 122.